This is the screencast for section 2.7, example 7. We're going to design a juice can. The Stewart Cannery will package tomato juice in 2-liter cylindrical cans. So that's talking about its volume. Find the radius and height of the cans if the cans have a surface area of 1,000 centimeters squared. So I'm dealing with two concepts, volume and surface area. Well, I know that the volume of a can is pi r squared, the surface area of the top, times the depth, so h. I know that the surface area of the can is going to be 2 circles, so 2 pi r squareds plus, now if I unrolled this label, it would be a rectangular shape that the height of it would be h, and then the other dimension, so I guess the width, would be the circumference of this can. So that would be 2 pi r, the circumference, times h. So now the problem says that the Stewart Cannery will package tomato juice in a 2-liter cylindrical can. So the volume is in liters, but the surface area is in centimeters squared. So I'm going to change liters into milliliters because milliliters and centimeters cubed are the same. So we'd be on the same unit if we were using milliliters and centimeters squared. We'd be using the same basic unit. So 2 liters is 2,000 milliliters. So I'm going to put 2,000 in for volume. And then the surface area is 1,000. So the question is trying to find the radius and height of the cans. So since I need to find both of those variables, I'm going to pick the easiest one to solve for, which I think is going to be h in the volume. So I'm going to divide both sides by pi r squared. And I get that 2,000 divided by pi r squared is the height. So now I can take this expression for height and plug it into the surface area. So I have 1,000 equals 2 pi r squared plus 2 pi r times the height, 2,000 over pi r squared. Now it's just a matter of solving for r. Well, that seems a lot more complicated than it's worth. So what I'm going to do is I'm going to graph the left side into y1, the right side into y2, and find their intersection. So I put 1,000 in y1, I put the right-hand side, that complicated mess, into y2, and then I adjusted my window. I thought, well, first of all, if y1 is 1,000, my y-max has to be above 1,000, so I made it 1,250. 1,500 would have worked just fine. And then as far as my x's, I'm like, well, what good radius would there be? Because x represents the radius of this can. And at first I'm thinking maybe out to 10, but then I graphed it and I saw that 15 was a better possibility to create a good window. I found the intersections and I see that if my radius is 4.62 centimeters, I will get a, let's see, 1,000 was the surface area. I'll get 1,000 for the surface area. And then also, if my radius is 9.65, I'll get 1,000 for the surface area. So I have two possibilities. The radius can be 4.62 centimeters or 9.65 centimeters. So now what I need to do is find out, I'm going to use these radii to find the height of the curve. So because my cursor is on the x coordinate of the intersection here, I can quit and tell my calculator to take the formula for finding h, 2,000, divided by, and then put my denominator in parentheses, pi, and instead of using r, I'm going to use x squared because my calculator has stored that x value that was on my graph as its temporary x value. So if I hit enter, I get my h value that goes along with 9.65 centimeters for the r value. I can do the same thing for my other intersection. So since my cursor is on the intersection for the other 0, I can quit off of the graph. Now I can actually just hit up twice, just twice, and then hit enter. And now it's going to reuse that same equation, but now x has a different temporary value, the value from the other radius, that I found as the intersection. And now I get 29.83 is the other height of the can. So I have two scenarios. If the radius is 4.62 centimeters, the height of the can will be 29.83 centimeters. If the radius is 9.65 centimeters, the height will be 6.83 centimeters. The now try problem for example 7 is number 37. So the Drake cannery will pack in a half-liter cylindrical can. So as we discussed before, that would be 500 milliliters. Let the x be the radius of the can in centimeters. So let x be the radius, not r this time. So I've got the volume of the can, 500, equals pi x squared times height. And then the surface area of the can, which is S, is going to be the same problem as before. So 2 pi, this time x squared, plus 2 pi x times h. So the two circles on the top and the bottom, and then the rectangular shaped label that would peel off the can. Now, again, the problem says express the surface area as a of the can as a function of x. Okay, x is the radius. H needs to disappear. So I need to find something that h equals that has x in it. Well, that comes from this other side. So I'm going to divide both sides by pi x squared. And I get 500 over pi x squared equals, let's see, that'll cancel. So that's h. Now h has a formula or an expression that it equals that only has x variables in it, so I can plug that into my surface area. 2 pi x squared plus 2 pi x. Now instead of h, I'm writing this expression that has 500 over pi x squared, only an x in it. It only has an x in it. So I have expressed the surface area S of the can as a function of x and x only. H is gone. Part B asks us to find the radius and the height of the can if the surface area is 900 centimeters. So similar to the last problem, I'm going to set the surface area to 900, put 900 in Y1, and then the surface area formula that I just got from part A in Y2, find a good window, and find the intersection. So now that I've found the first intersection, I'm going to use that x value to find the height that goes with it. So I'm going to use 500 divided by pi x squared in my calculator. So I get a height of 35.42 centimeters when the radius is 2.12. And now that the intersection is on, now that the cursor is on the other intersection, I can use that specific x value. I just hit second enter. And the new height would be 2.71 when the radius was 7.67. So again, we have two possibilities that will give us what the question asks for, a surface area of 900 centimeters squared. If we have a radius of 2.12 centimeters and then a height of 35.42 centimeters, so this like tall skinny can, that'll give us a surface area of 900 with a 500 milliliter volume. Or a radius a little bit more tuna-shaped can, I guess, a 7.67 centimeter radius can that only has a height of 2.71 centimeters. So this is a very flat, wide can, but it will also have a a surface area of 900 centimeters squared and a volume of 500 milliliters.